Okay, this is 1.6 day 1 combinations of functions. That's multiplication. It's not f of g. Here are the pair of functions. And find domain. So f plus g f plus g. And to find the domain, we want to make sure we do that before we combine and simplify. So let's look at the domain of f. F, it's rational. It's undefined when x is -1. So we have all real numbers except for 1. And let's put it on a number line. So -1 is not in the domain. And g, radical, we need to have this be 0 or greater. So that means we want everything from 1 to the right. 1 to infinity, 1. It's okay to equal 1, so we use a closed circle. We're going to go like that. And then we want to make sure that the domain that we want is the overlap of both of these. So if we look at, is this point in both domains? No, it's only in that domain. Is -1 in both domains? No, it's in neither domain. Is 1 in both domains? Yes, it's here and there. Is 2 in both domains? Yes, there, there. So we're going to go from 1 to the right and 1 to infinity, including 1. And here it's the same domain. F times G. So we could just write it like this. But we still have the same domain because this has to be 1 or greater, and this cannot be 0. So we still have the same domain. F divided by G, we'll take F divided by G so we could write that like this. And now we need to be careful about something that makes this 0. We can't have a -1, but here we can't have a 1 anymore. So looking at the domain of the radical of G, if we just look at the radical, 1 is okay, but if we have a radical in the denominator, then this can't be a 1 anymore. So we're going to go from 1 to infinity, but we don't include 1. Okay, you do the same thing with this. Do the same work and pause, then turn it back on and check your work. So we're going to go F plus G. And let's look at the domain of F. F is rational. It can't have a 0 in the denominator. Open circle. We're going to go either way there. G, all real numbers. And we want to have the overlap of all real numbers and this. So the domain is going to be -infinity to 0, 0 to infinity. F minus G. And we'll have the same domain. F times G. And same domain. F divided by G. F divided by G. All right. So we can't have this be 0, and we also can't have this be 0. So we don't want 2, and we don't want 0, but everything else works. So we have to go -infinity to 0, and then we'll go 0 to 2, and 2 to infinity. So combinations that we just looked at, adding, subtracting, multiplying, and dividing, are not very complicated, but here's a type of question that makes you think a little bit. So let's find f of negative 6. So f of negative 6 plus g of negative 6 equals 2 over negative 6 squared plus 1 over negative 6 minus 1/3. We want to find f of negative 6, so all we have to do is get that by itself. And we know what g is. It's 2x. So now we can just have, or we can just move it over there. Minus g of negative 6. So I just moved that over there. And now we're going to solve. We'll have what f of negative 6 is. Six over 36, 12 over 36, and then g of negative 6. G is 2x, so this is going to be 2 times negative 6, and that will be negative 12 I guess we'll go back down to 18. Divide by 2, 3 over 18. Divide by 2, 6 over 18. And then we'll have plus 12. So we get negative 8 over 18 plus 12. And we end up with 104 over 9. All right. And then f of x plus 1. All right. So all I did was I'm copying all of this, but it wanted f of x plus 1, so replace all the x's with x plus 1, and that's how we got this. And we need to isolate f of x plus 1, so we'll just move this over to the other side. And also remember that g of x is 2x, so g of x plus 1 is 2 times x plus 1, 2x plus 2. We're going to have f of x plus 1 equals 2 over x plus 1 squared and then we're going to go minus g of x plus 1 . Alright, and we're going to get a common denominator. Everything needs to have an x plus 1 squared and a 3. So this is going to be 3 on top, 3 on the bottom. And we have to multiply top and bottom by 3x plus 1. And we need to multiply top and bottom by x plus 1 squared. And then g of x plus 1 is 2x plus 2. So that'll be 2x plus 2, we'll just leave it like that, 2x plus 1, and we need to have 2x plus 1. We need to have a denominator of 3x plus 1 squared, so we multiply the top by 3x plus 1 squared. And let's just do a little simplifying, but we won't expand it. Here we'll have 6x plus 1 cubed, 3x plus 1 squared. And let's just have you think about it a little bit. Think of how this became that. Why did we do that? And the reason is we want to combine all these with a common denominator. So we're going to have the common denominator be 3 times x plus 1 squared. So to get this to look like that, we have to multiply the top and bottom by 3x plus 1. So 1 times 3x plus 1 will give us that. And multiply this times 3x plus 1, and we get 3 times x plus 1 squared. All right. You try this one. Pause the video. You work this out, and then check your answer. So we want to find f of -6. And that means we're going to put a -6 in place of all the x's, and then get f of -6 isolated. All right, we need to evaluate this so we know what g of x is. So now we know that this will be a radical 7. And we have, this will be a -18 times 36, radical 2 over -6. And let's do -648. We want this by itself, so we're just going to add this and add this to both sides. All right, let's try f of x plus 1. And we have g of x plus 1 f of x plus 1, 18x plus 1 squared, x plus 1. And we just want to get f of x plus 1 by itself, and we have to replace this. So g of x, and then we'll say g of x plus 1 equals 1 minus x plus 1. Okay, and don't worry about the negative because this will be positive when x is negative, so it's okay to write this. All right, so g of x plus 1 is radical negative x. This would be radical negative x. And let's distribute that. And then we'll just move all this to the other side, and we'll have f of x plus 1 by itself. All right, almost done. Okay, that's f of x and g of x. Negative 4, 5. Negative 3, 3. Negative 2, 2. Negative 1, 3. No. Negative 1, 1. 0, 2. 2, 4. Okay, so this says f of negative 2 minus g of negative 2. So let's look on the graph f of negative 2. Here's negative 2, and f is 1. G of negative 2, and that is 2. Okay. All we have to do is find the values from the graph. So you pause it, try the next 3, and then restart. F of 1 plus g of 1. F of 1 is 3. G of 1 is negative 1. So we get 2. F of negative 3 times g of negative 3. Negative 3, f is 2, g is 3. F of 2 is 4. No, f of 2 is 2. And g of 2 is 4. So we get 1/2. All right, and that's the end.